So formal specification basically means a description of the protocol that does not have any significant opinionation in it. So it's sort of like a very pure description of the protocol. A pure description of the protocol can't really be done in anything other than a very pure language. So you wouldn't really want to do it in English. You wouldn't want to do it in a machine language. You'd want to do it in a very conceptual language. And you know, as it turns out, maths is a pretty unopinionated language to describe how a protocol should work, because it specifies only correctness rather than being forced to specify how something should be achieved, right? Maths doesn't really allow you to specify how something can be achieved. I mean, you can dance around it, but it's not something that you can, because there is no general maths computer, right? Maths is really a language for specifying what is the correct outcome. Now, of course, if you only describe what is the correct outcome, you could end up making something that is unimplementable. For example, you say the correct outcome of the system is the piece of data which, when hashed cryptographically, results in all zeros, right? Now, that's perfectly specifiable in maths. Nothing problematic about that at all. But it's impossible to implement as far as we know, right? So care has to be taken that when you're specifying correct behavior, it's possible to implement a practical machine that does do that. And normally you have to tie your formal specification to a real implementation so that you can see both you have the correct behavior on the one hand and you have a demonstration that it's practically possible on the other hand. But if you skip the thing that says what correct behavior is, then you end up with all of the stuff, all of these elements of making it work practically on some particular platform, whether it's, you know, x86 machine code or Python or Haskell, right? On some platform, not specifying simply what correct behavior is. You can say, well, correct behavior is what this thing does, but then what that thing does may have very particular platform-specific considerations because it needs to actually make it work. It's specifying when you have an implementation, you're specifying how something should be done, not what should be done. And there is a difference between this. To take a simple example, a sort of an analogy, you might see someone cook a meal, right? Now, if you see someone cook a meal 100 times, you're probably going to work out which bits that they do are the important bits and which bit that they're doing are not important, because that changes between the different examples. But if you have simply one example to go off, if someone, I don't know, and maybe that example is you're not able to watch them in person, but it's actually a film of them doing it. And therefore you've got the opinionation of the filmmaker in addition to the chef. Then you are stuck with not knowing which bits are important and which bits are not important. Yeah? And you end up with, you can end up with a cargo cult forming. basically someone reproducing the unimportant bits and missing some of the important bits. It becomes dogmatic, indeed, because you're not specifying what correct behavior is. You're giving an example of something that exhibits correct behavior, one would hope. But from that example, it's not always so easy to determine which bits are correct behavior and which bits are incidental behavior. And now, of course, you can tie, you can say, well, this bit is incidental, this bit is correct, and da-da-da-da-da. And of course, you can try and use an implementation language to express correctness alongside a lot of comments and commentary and an annotation. But ultimately, you're still going to have quite a lot of opinionation, accidental opinionation, unintended opinionation, unknown opinionation. It's still going to be in there. It always is. When it's a person writing it, it always is. But when you use maths, it forces you to be. My opinion is it forces you to be a lot more. It makes it a lot harder to be opinionated, because maths really, really makes it hard to express anything other than correctness. It's still possible, but it's really hard. And especially if you force yourself to put it not merely in maths, but in the simplest, most concise form of maths. So you really limit how much maths you have to play with, how many symbols you want to use, how many formulas you're going to put it in. Again, this reduces the possibility of opinionation, because you're forcing yourself to adhere to this metric, to respect this metric of conciseness. Essentially of reducing the amount of information in what it is that you're presenting. You can't do the same thing when it's implementation, because implementation languages, their form of conciseness, they're made for expressing not correctness, but rather how to do something. If I have a small program in C, probably if I try to compress a program in C, it's probably going to use lots of pointer arithmetic, because C, it turns out, is really expressive for things like pointer arithmetic. If I have a very short program in, Intel Pentium MMX machine code, that does a lot of work, then probably it's going to have lots of the CISC instructions that were introduced in the MMX, because this allowed you to do more stuff in a shorter amount of space. Again, in both cases, it's about the designer of the language and their ideals that come through when you're pushing for a very, very short expression. If you force yourself into maths, there wasn't really a designer of maths, right? Maths is really, set theory is really quite a minimal construct for expressing correctness, expressing axioms, right? Axiomatic systems. And so by forcing yourself to be as concise as possible, you are in some way optimizing for the purity and opinion and non-opinionatedness of your work. So yeah, the vision is at this point is to stop the relay chain and start the jam chain and migrate everything over from the relay chain into the jam chain. Because the thing is, the parachains, what you can look at the relay chain doing is just having an application. It's an application, right? It's the parachains application. Well, that application, that service, parachain service, that Jam can host services. And the cool thing is that Jam can host lots of different services. And we can write a service under Jam that is the parachains service. So we can actually write what it is that Polkadot is doing, the relay chain is doing it right now, as just a service in Jam. And then we can add other services to Jam later that use what Jam provides in different ways. So the thing is, the relay chain needs to combine. Like you can look at if you imagine each of the relay chain looks also a bit like a flower, right? Each of the petals process a parachain. Okay, they make sure the parachain is one block of it has been executed correctly. And then you say, well, what's the middle doing then? What's the center of the flower doing? Well, actually, what it's doing is it's aside from recording where the parachain is at, like the parachain's current state, it's also relaying messages between the parachains, hence the relay chain, right? It's also providing this sort of data conduit, and it's also giving messages back again. It's telling the chain which messages it should also be receiving. So it's able to both receive messages from the parachain and tell the parachain which messages it should be looking at. So it does all of this stuff. That's basically what the center of the flower does. But the thing is, that center of the flower is kind of hard-coded on the relay chain. I think in principle, it would be possible to evolve the relay chain, but I think it would be a sort of death by 1,000 cuts, because it would be a lot of evolution, and every step in this evolution would be breaking, and parachains I think they would tear their hair out with this each of these breaking changes over and over again. So my feeling here is to there's one other reason as well, which is technical debt. There's quite a lot of technical debt on the relay chain now. So initial design decisions that turned out to be maybe not optimal. And you've made changes. But the thing is, those changes are generally required you to implement the thing that there is now in a not so great way, because you had to take account of the fact something else was happening before. And that's really where we're at. We've done, 5 years of coding. How long has it been? Started 2018. Yes, six plus years of coding on Polkadot, right? We have a pretty solid idea about how to make these kinds of systems work. And it's different. You didn't have quite the same understanding of how to design these systems at the beginning. And so it makes sense now, with such a substantial change point, I think, to sort of start afresh and start with a slightly different approach. It'll be work to do this tooling and to make it nice and super smooth, but it's a one-off thing. And at the end of the day, if the migration takes 4 hours, and it means that finality suspends for that period, it's not the end of the world. Parachains would still keep going. It's just that they wouldn't be finalized. So anyone who was doing anything of any significant value on the parachain would probably want to actually fully synchronize the parachain, or connect to a synchronized node that they trust for those 4 hours, right? And then after that, it starts getting rejigged by the Jam chain, and everything is good again. So yeah, I mean, I think that 4 hours is probably an overestimate. Realistically, it's probably the case that it can be, it could probably be migrated, in I'm going to pick a number out of the air now, 15 minutes. But the point is that it's a one-off thing, and it can be prepared for, and it can, it's a pill that you take once. And when you've taken it, you've cleared yourself a huge amount of technical debt. And there are a few other advantages, one of which is the ability to have a formal specification, which isn't something that we could do if we kept on the current track of using Substrate.